Hi, my name is Jason Clark from South Dakota State University Extension, and today we're going to continue talking about the nitrogen cycle and how knowing that nitrogen cycle can better help us make decisions with our nitrogen management on our fields. So to this point, we've talked a lot about how we can use urease and nitrification inhibitors. These can help us slow down or decrease the amount of volatilization loss, the amount of nitrate loss through leaching, and also through denitrification processes. But there's also a couple of other things we can do as well. One of those methods is using slow-release fertilizers that when they get applied to the soil, water infuses into the fertilizer through a protected layer and then slowly diffuses out throughout the season, giving the crop the nitrogen it needs closer to when it needs it as opposed to all up front. And also using split application where we put some on at planting and then the rest closer to when that plant needs it. And today what we're going to look at is how well do these two approaches work, and also a lot of them all together work in eastern South Dakota. So let's go ahead and get started. So basically, in essence, we're going to look at single applications, split applications, slow release applications, and also single applications with an inhibitor. See how well they did. So that's our objective. So our urea applications, we're doing a single pre-plant and a split application. With inhibitors, we're using a super U coated urea that has a urease and a nitrification inhibitor. And then we're using slow release fertilizers and already on the market ESN, or environmentally smart nitrogen, at a 100% ESN, a 1/3 urea plus 2/3 ESN, a 2/3 urea plus 1/3 ESN. And then we have 3 biochar coated ureas, both at 100%, 1/3 urea, 2/3 urea, and the rest as the biochar coated. So we have those slow release fertilizers, and we're going to see how well they did. So in this project, we did 2 locations across 3 years, one in Brookings County and one in down near Beersford at the research station down there. And that's where we're going to look at. Volga's a tillage location, Beersford's is no-till. So here we're going to look at our grain field. We're first of all going to start at 2022 in Beersford. We got our grain yield here and our treatments down here that we'll walk through. So first of all, we'd look at a 0 nitrogen, so we know if we didn't apply any nitrogen, what yield would we get? And then we look at once we do apply urea, we do see a response, which is good to note. About here, it's about a 16 bushel per acre response, which is not high when we had nitrogen, but it was a very dry year in 2022 in Beersford. Now, if we split that nitrogen application, we also get a decrease in yield, which makes sense in a dry year. If we don't have moisture to move that second application in during the season, then it sits on the soil surface and can be lost. Now, if we use Super U with an inhibitor, we do up that yield compared to a split, but not as quite as a single urea application, meaning that moisture maybe didn't incorporate the Super U as well. We're not really sure on that one. Now, once we move to these polymer-coated ureas, these slow release, we have 100% ESN that did really well. We had 1/3 urea plus 2/3 ESN, 2/3 urea plus 1/3 ESN. You can see the 100% ESN just did just as well as the 2/3 urea and 1/3 ESN. The idea of the mixes is that we're getting some quick release nitrogen and some slow release. And if we can lower the cost of the slow release ESN by adding in some urea, that also helps us save some money there. So we know here 100% ESN or 30% ESN, we did just as well. Now once we start doing the biochars, we see the 100% biochar did better than when we mixed it with urea. We look at B, we see 100% and 1/3 urea with biochar did well, but once we had 2/3 urea, it didn't do very well. And biochar C, it didn't matter which one we used as far as percentage of urea and biochar, the slow release did just as well as the other ones. So overall, looking at here, we see that our 0N, our split application, and some of our biochar-coated mixes with urea didn't do as well, but all the rest did just as well. Whether it was plain urea, Super U, 100% ESN, or some of the mixes, they did just as well and performed very well. Now, if we move to 2022 in Brookings, instead of it being dry as in the southern part of the state, we were actually quite wet. Now, this year at the 0N, we did 149 bushels. Once we added nitrogen, we increased that about 30 more bushels per acre with plain urea. When we split that urea, very similar yields, so single or split application of urea. In 2022, it didn't matter. If we did a Super U application, decreased yield just a little bit, but not a lot. Once we added those polymer-coated ureas, 100% did a little bit better than the 2 mixes. So it shows we needed to kind of slow that availability. Now the biochars, we see pretty similar response, whether it was a mix or not. Biochar B, very similar response, a little bit less than 100% ESN. And biochar C, didn't matter the percentage that we used, 100% or less. all yielded pretty similarly. So overall, looking at here, we had lower yields with the 0N, the addition of Super U, and some of the mixes with the ESN, as well as the mixes with some of the biochar. So these treatments right here did best: plain urea, split urea, 100% ESN, and some of the biochar slow-release fertilizers did really well as well. All the rest lower yield. Now if we move to 2023, in the Brookings area, our 0N only yielded 111 bushels per acre, but once we added nitrogen, we upped it about 90 bushels per acre of urea, so that's a really good response to nitrogen. If we split that nitrogen application, we did just as well as a single. We added those inhibitors of Super U, did just as well. Now we have the ESN and the mixes with urea. Again, did just as well. The 2/3 urea, 1/3 ESN did a little bit better, but not much. Biochars all did fairly similar. B and C all did similar yields. So in this year, it didn't really matter what you did. You almost couldn't go wrong as long as you added nitrogen to the system. You got a large 90 bushel per acre increase by adding nitrogen, whether you added urea, split it, Super U, NESN, or another slow release. Now if we move to 2023 in Beresford, this is kind of an interesting year, pretty even rainfall, but no difference as far as yield goes, no matter what we did. And we also, a big part here to look at is this 0N yield of 218 bushels, which was just as high as any of these other treatments. So in this field in this year, we actually didn't see a response to nitrogen. So no response to nitrogen means probably the product wouldn't matter anyway. And none of these products were lower or higher in 2023. Now we moved to 2024, which was really wet. It actually drowned out our Beresford, so we only have our Brookings location in 2024. Our 0N yielded 133 bushels. We add urea to the system, 208 bushels, so that's 70 bushel increase by adding nitrogen. Now we have our split nitrogen application, increase our yield even more, so it was a really wet year, so that split application helped not lose as much early in the season like that single application of urea, but kept it available, and so it increased our yield by about 20 bushels per acre. Now if we move to adding Super U with that inhibitor, single application, so you don't need to go across the field twice, very similar to split, just a little bit more cost with the inhibitors on there. Now if we move to ESN, all of them did very well, whether it's a single application, 2/3 urea or 1/3 ESN. Our biochars, we can see the 100% did the best, and then as we added urea to the system, we decreased yield. Biochar B, same story, 100% did the best, increased urea, lowered yield. Biochar C, didn't matter which of the three that we did as far as mixes are 100%, they all yielded well. So the best treatments in 2024, which was very wet, are the ones that lower yield were just plain urea, 1/3 urea plus 2/3 ESN, and some of the biochar mixes with urea. So in summary, if we look at this, we want to know which ones yield the highest the most often. So if we have to make a decision, because a lot of times the weather we can't decide before we make a nitrogen management decision. So which is most often going to get us the best yield? Urea 4 out of those 5 times, split urea 4 out of 5, Super U 4 out of 5. ESN was actually in all 5 instances, it was at the top yield or as high as we got, similar to other yields. Once we add the biochar coated fertilizers 4 out of the 5 times, we mixed it with urea. On 1 of the 5 times, it was the highest yield. The biochar B 4 of the 5 times, mixed it 1 of the 5. Biochar C 3 out of the 5. Mixed with urea didn't help it. So the biochar coated ureas didn't do as well as we were hoping, but most of the time, if you did 100%, they did just fine. But really the biggest thing here is it didn't really matter which one we use, except for ESN in all 5 instances had the highest yield in the mix or one of the highest yields. But if we use urea, split the urea, use the inhibitor with Super U, in one of those 5 instances, we all had a yield reduction, usually due because we all have similar fine textured soil, so we're not losing it because of coarse texturedness, most likely denitrification, losses there, or volatilization in the no-till. So we see in each of those instances, at least 1 out of the 5 years, we're likely going to see a decrease unless you use the more expensive ESN polymer-coated fertilizer. So that's kind of what we learned about slow-release fertilizers versus split and single. Is usually in some instance, no matter what you're using, you're going to probably have an off year. But if you're protecting that nitrogen and getting it in the soil and keeping it there, that's probably your best bet. And you might lose 1 year out of 5, but most likely you're going to, over the long run, you're going to do really well. So thank you for your time today, and I hope this answered some questions for you.